Many new engines are experiencing excessive oil consumption, as well as oil and fuel dilution issues, increased maintenance costs, engine knocking noises, and in many cases, catastrophic engine failures are now resulting because of direct injection that's been applied to almost every single modern vehicle. With the effort for improved efficiency, economy, and output and performance, unfortunately, there's some major drawbacks to this new technology in the design of many brand new engines. Let's talk about direct injections, the pros, the cons, and what you need to know. Let's get into it now.
Life's too short to drive boring cars.
Fuel injection systems have gone through multiple changes. Years ago, you had carburetor. You had a big bowl on top. You mixed a little fuel, mixed a little air. It sort of broiled together and dumped it right down into the engine, more or less. Then you moved into, different types of fuel injection system, most of which are pretty much what we know today as port fuel injection. They grab some fuel, they put some air, they mix it together, bring it into a common plenum, and then they inject it into each individual cylinder. It's already pre-mixed, and that fuel is injected upstream of the intake valves, which does two things. Number one, gets the fuel into the system. The valves hold back, of course, the fuel and air mixture and opens it when it's needed. And that fuel mixture tends to wash the backside of the valves, which is a positive benefit of some of the older port fuel injection type engines. And while port fuel injection wasn't necessarily the most efficient process, it worked. Vehicles turned over, they ran, and they ran very well. Then manufacturers started creating smaller engines. They're looking for maximum efficiency. They're trying to extract as much performance and economy out of a lot of these brand new engines. That's why we're seeing a lot of these turbocharged 3-cylinder, 4-cylinder engines. And how are they going to maximize the performance from that? Not just turbocharging, not just higher thermodynamics, as well as a higher static compression ratio. They also improve on the fueling systems, where now they put a high pressure fuel injector right in, pushing fuel right into the combustion chamber downstream of the intake valves. Now what that does is provide better fuel metering, as well as better efficiency and ultimately better performance. Gives the smaller engines a better output, a better thermodynamic, as well as it generally creates a more consistent and reliable drivetrain. But now, unfortunately, as a lot of manufacturers are starting to realize, the very design of direct injection creates all kinds of new challenges that they didn't even consider. New challenges that end up costing the consumer, like you and I, after several years of ownership. Because now increased maintenance costs go up. Of course, you need to pay very close attention to the type of fueling, and carbon fouling is just a massive new phenomenon that you never saw before in standard port fuel injection type engine. So here we have a valve. This is an engine valve. This would be, for example, represent an exhaust valve, but for all intents and purposes, these valves open, let fuel and air in, close, ignite. And so this is what the valve does. Now, in a direct injected system, the combustion chamber where the igniting happens, the fuel gets pushed right in to the top of the valve, into the combustion chamber. So you're getting this fuel in here. But what you actually get is a scenario of you get excess carbon fouling, carbon buildup everywhere in the engine. You get it all over the backside of these valves. So the intake valves get very clogged up, reduce the efficiency of the valves. Also, a lot more carbon fouling starts to develop within the engine itself. So it's not uncommon to find a huge collection of carbon all over the top rings, the compression rings, all over the cylinder walls, and generally it creates a reduced thermal capacity, thermal efficiency of that engine. You also start developing knocking noises, strange sounds, and not only that, it also creates a strong demand for increased maintenance. Yes, every 30,000 miles is generally the recommended maintenance, where you have to basically wash the intake system, wash the intake manifold, wash the intake valves, because these are all clogged up, and ultimately it essentially washes a lot of the carbon off of the top side of the pistons and the top compression ring, where a lot of that carbon tends to build. Now, a little extra maintenance isn't the worst thing in the world, but the problem is it doesn't begin and end with this 30,000 mile maintenance factor. It doesn't begin and end with just applying a catch can. It actually can result in catastrophic engine failures. And I personally know many mechanics, I personally have seen it, engines that are knocking and essentially shot, where they drop their compression. Most engines are running 150 to 180 pounds per square inch of compression when you run a compression test. And a lot of these end up blowing a hole, or you end up with a catastrophic engine failure where all of a sudden you drop down to 30, 40 PSI because the engine and that particular piston finally blew apart. Whether there's broken ring lands, particularly on the top, broken rings, or just a hole in the piston, they're often results of what is created by direct fuel injection. And how is that? A lot of people think, oh, just use great fuel. Is fuel the answer? But here, when you're looking at your fuel door, it always gives you the recommended 91 octane in this case, and this is where you fuel it up. If it was just a fueling issue, then most people wouldn't have a problem because most people follow the recommended procedure, and it's rarely, if ever, related to the fuel issue or a shortage of the fuel octane, which is the resistance to knock or engine knocking or detonation or pre-ignition. It's rarely a fueling issue when we're talking about a direct injected engine. Conventional engines, absolutely. When we're talking about a conventional engine, having pre-ignition prevention with the proper knock prevention by using the right octane is the measure you need to take. But sadly, with direct injected engines, rarely does the fuel become the issue because it's actually called a low-speed pre-ignition. LPSI is a condition that's derived from direct fuel injected engines. And it's a very unique condition. Direct fuel injected engines actually have a multitude of issues. Let's talk about another one, and it's the oil and fuel dilution issue. Now, a lot of these engines, as Honda unfortunately realized, by applying direct fuel injection, what you're doing is putting fuel into the combustion chamber. A lot of times when these engines are cold, parts don't tighten up as much as they could. Now, of course, when an engine is also cold, you don't have that ring of oil, that film of oil in and around the piston rings. And because you don't have that film of oil, what often you have is a bit of dryness around there. You don't quite have enough lubrication, and the seal around your piston rings isn't quite adequate yet. So applying heavy doses of high pressure fuel directly into the combustion chamber, particularly on a cold engine, often means you're going to start pushing fuel past the rings down into the bottom of the engine, where you're now mixing fuel and oil together, and you're actually diluting the oil that's made to lubricate and protect your system with fuel, which is actually a solvent. And a solvent will do a couple of things. It's washing away oil where you don't want it to be washed. You want rod bearings, you want cam lobes, you want piston rings, you want it all to be lubricated, but unfortunately all of that gas that winds up down in the bottom of the engine or on the bottom of the piston rings essentially washes a lot of that oil away, and you can often wind up with scoring on the cylinder walls. You can wind up with catastrophic rod bearing issues, crank journal issues, cam lobe wear, and a whole lot of multitude of issues in those engines simply because the solvent has gotten into places it really shouldn't. And that's what Honda was finding out with their 1.5 liter turbo 4-cylinder engine and a lot of other engines. We're hearing directed to GDI engines in the Hyundai and Kia Theta 2 engines and a whole host of different motors that have issues directly related to the direct injected engines. But a much bigger issue comes from direct injected engines than just frequently changing your oil and casual warm-ups, which is highly recommended by many brands, including Honda. Unfortunately, catastrophic engine failures are happening at a significant rate, and a lot of it has to do with the sludge buildup in these engines. And what it's actually called is the low-speed pre-ignition condition, as I already mentioned, LSPI. So what ends up happening is all of that carbon that's sitting on the top of the piston rings on the combustion chamber start to build up. There's extra material, there's extra carbon there, there's extra fuel, and sadly, even a lot of the oil that sits up on top of there is pre-ignited. So there's a condition, particularly when you're driving your engine under a low RPM and heavy load. So you're a low RPM, you're maybe 1500, 1800 RPM, and you're flooring it and you're trying to get going. Well, that turbocharging is putting a lot of extra boost pressure in the engine, and that now combined with the extra carbon in the intake and within the top end of the pistons creates all of these high pressure spikes. Most engines can operate up to 300, 400, 500 PSI at the maximum, but unfortunately there's many conditions where a lot of these engines now are subjected to over 1,000 PSI of pressure spikes every once in a while, where you're getting a lot of that carbon material in the engine compartment in the combustion chamber are pre-igniting out of sequence, out of cycle. Not just while they're supposed to be running and firing, but in between firing. There's a fire, and then there's a fire, and you get these in between random events where it's like taking a hammer, a ball-peen hammer on the top of your piston or on the rings, and it creates these conditions. Particularly low-speed engine running conditions can cause a big part of this, because a lot of that carbon material, including the oil now that's used to lubricate the rings, are also pre-igniting in some cases because of this heavy load condition, and because this high pressure coming in from the fuel system is causing a whole host and multitude of issues and catastrophic engine failures, where the rings, the ringlands, the pistons are all subjected to major failures. And it's happening. Many mechanics are seeing this. It's a new phenomenon, and it's a new science that a lot of mechanics are just starting to figure out now. And so while many manufacturers have created a whole new problem with direct injection, which can result in catastrophic engine failures or knocking or excessive oil consumption, because also remember, when you're washing that oil away, you tend to get more oil up past the rings because it's no longer lubricated properly, and a lot of direct injected engines tend to consume oil. So the ultimate solution is prevention. So understanding what the problem is and how to prevent that. So obviously, frequent oil changes with the right grade of oil, and I'll explain that in a second, is one of the big preventative measures. But a lot of people are also saying, how do I eliminate a lot of that carbon in the first place? Well, we know a lot of the gas recirculation happens because a lot of these systems now take a lot of those fumes that come off of the engine in the crankcase and recirculate them back to the intake. Well, now what are you doing? Adding more of those oil fuel droplets, and it's dropping in there, creating more carbon buildup on the intake. Of course, that's just adding more fuel to the fire. So a lot of people are putting in catch cans. So as that recirculation comes around, instead of re-putting that oil and those fuel particulates and all of that back into the engine and the intake side, it's actually dropping it out and condensing it into a little external can. That's preventing a lot of the extra issues, and that itself is slowing down the process of deterioration. So right there is one of the big preventative measures, and a lot of people underestimate the importance of the grade of oil you're putting in. And while everybody thinks, okay, I'm putting in a good brand, you look at the manufacturer, is it reputable, you believe they have it covered, you look at the right weight, and all of a sudden you think, okay, I've got all my bases covered. But you couldn't be further from the truth. Because now there are new formulations that a lot of these OEMs, these oil manufacturers, are having to create to prevent a lot of these detergents, this bilge, this sludge buildup that's coming from fuel and oil. They're trying to eliminate that in the first place. And oil is actually the key ingredient to prevention. Where standard garden variety pre-ignition conditions or detonation is usually caused because of a low grade of fuel, this low speed pre-ignition direct injected style detonation and engine damage is caused largely because the type of oil and the type of balance of detergents that go in the engine. Now, when you turn your oil jug around, it's always going to have these standards, and this is critically important when you're picking and selecting the right oil that can make or break the life of your brand new direct injected engine. So the owner's manual generally has the latest and greatest, but definitely do a search, ask your dealer, ask your manufacturers, figure it out, look it out. Don't change your oil without first looking into what your vehicle needs. Look in the owner's manual, it's going to tell you exactly what you need. But look at the specs here. You'll notice this one here says ILSAC GF5, ACEA A1, B1, but look, API SN, SMSL. Now those all matter because there's some major changes to the industry. What we're talking about is the latest and greatest. What you had was an SN Plus, which is the first effort in transition, or the transitionary phase of creating a product that was good enough for a direct injected engine. It was tested on a lot of the Ford EcoBoost engines. So the SN Plus, as you see right there, is what they needed for a while. Then they came up with another derivative. So as these formulations improve and you're getting a lot of better oil, you're finding a lot of changes to the oiling. And so these specifications change the level of detergents and how much you can actually combat a lot of this direct injected carbon fouling. For example, GF5 is no longer. What you want is GF6 or GF60. Now, while that's almost brand new to the market, that's in fact what many of these engines are going to require. Unfortunately, the GF6 or 60 is only good up to 10W30. If you're utilizing a heavier grade of oil, there's a good possibility you're going to need something along the lines of an SP. because that's then going to cover the heavier, thicker oil that you're going to often need to take hold of these preventative measures to, again, keep your direct injected engine lasting much longer. So when you're looking at your oil jugs here, it's imperative not only that you look the grade, the weight, the manufacturer, but you're meeting all these detergent criterias here and you're buying the right grade of oil. You have to talk to your manufacturer, your vendor, your dealer, and ask them what type of oil are they using. They should already know, but it's always worth asking that question. So as I mentioned in a very popular recent video about why modern engines are not surviving, why they're dying much sooner than a lot of the older engines, this is another shining example of a specific technology that is literally holding the consumer by the scruff of their shirt. It's costing you more money, more administrative controls. We're creating new solutions for problems that yet we've created. Unfortunately, the regulations, government, manufacturers are creating smaller engines, tighter tolerances, and the demand for better fuel systems or more improved performance additives like turbocharging, like direct injection, means a lot of these engines just are not built to last. Now, as I also mentioned in that video, no two manufacturers are the same. How does Toyota, how does Lexus manage to do direct injection and not have all these issues? Well, because they use a dual port and direct injection system. You get the benefits of the direct injected system, but you also have the port system that comes in and comes out to actually help wash away the intake, prevent a lot of these problems in the first place, and keep the internals of your engine healthy and running for many years to come. They're not the only manufacturer. For example, Lamborghini Gallardo in the later 5.2s and the Audi R8 use a dual port and direct injected system as well. And there are many manufacturers that are using that system to help prevent and combat these failures and these potential challenges now that manufacturers have introduced with the art of direct injected technology. And with all of that said, be sure to check out that video right there where I talk about the full summary as to why modern day engines are dying much sooner than the old stuff. Hope to see each and every one in the next one. We'll see you real soon. Bye-bye.